Thank you all for coming today. So today we have Jed from Taquito, which is a TypeScript library built for Tezos. So he'll give us show us a quick demo app, then do some live coding and go through some core concepts in terms of developing an app with the Taquito. So yeah, take it away, Jed.
Okay, thank you, Spencer. My name is Jev Bjorsel, and thanks for joining the webinar today. I'm going to step through a demonstration voting app that's built on a smart contract on the Tezos blockchain. So just a little bit about me and ECAD Labs. We build Tezos tooling for the Tezos ecosystem primarily. All our projects are MIT licensed, so everything is open source. Nothing's tied in with any sort of greater service, so you can use it as you wish with no encumbrances. And overall, our goal and why we do this is like we really like open source. We want to allow you guys to build things better and faster, and we just get really happy when we see new projects crop up in the ecosystem, and see that we helped in some little way. So a little bit about TypeScript. Taquito. Taquito is basically a library that sits between you, the developer, and the Tezos blockchain. It provides a lot of high-level abstractions to make your job of building things in Tezos a lot easier. So we have high-level APIs to do simple things like reading data from the Tezos blockchain, to making transfers, to signing operations, estimating the gas and storage for an operation, and also we have a kind of a neat smart contract abstraction. So I'll get into all of these in more detail towards the end. One of the things I will mention before we jump in is, so with Taquito, we're committed to supporting all the current and next version of Tezos. Tezos has on-chain governance, so it tends to upgrade quite frequently compared to other chains. And within those upgrades, there's a lot of work to to support the next thing. What our goal is to make that upgrade path smoother for application developers such as yourself. Taquito, the project is hosted on GitHub. It's developed in the open, so all our issues or pull requests and code reviews are on there. We always like contributions as well. Yeah, we're contributor friendly. Our website is tezostaquito.io, where you'll find documentation and all our API type docs as well. Okay, so how I'm going to do this is I'm going to show you a demonstration app, and then going to jump into a little bit of code in my code editor to just give you an idea of how it's tied together underneath. And then following that, we'll go through in detail some more of the core concepts of Taquito. Before I jump into the app, well, firstly, the source code for this little app is published on our GitHub org. On the link in the screen. There's a live demo for this, and also the contract source code is written in Lego. I'm going to speak a little bit about the smart contract that underpins this application before I go into the demo. Taquito is bottom up in that it reads Michelson and so on from the blockchain. It doesn't rely on any high-level languages such as Lego or SmartPy or Juvix or any of these other new ones. But this smart contract happens to be implemented in Lego, and it's useful to contextualize what we're doing here. So on the left-hand side is the source code for this contract, written again in the Pascal Lego syntax. And on the right-hand side, I have a little diagram. Now, the smart contracts in this smart contract, the lower part of this lists the entry points. That's vote, start vote, remove admin, add admin. We call these entry points. If you were to think about a smart contract as a class, these are essentially your methods on the class. On the upper part of this diagram, we have storage. And these are these would be equivalent of properties on a class. So you have proposal, which is data type string. We have a map of voters and votes. These track who can vote, because this is a permissioned contract, and what they voted. And then admins and end date. The storage in a smart contract is mutable, provided that there's logic to mutate it. So the properties at the top can be changed, assuming that there's entry points to actually do that logic on them. On the lower half, vote, for example, which takes a nat, a natural number, or an integer, that will affect the votes property in storage. There isn't a method to change the proposal name in this case. So even though proposal is in storage, it's effectively immutable because there's no logic to change it. We're going to build a little web application on top of this, or we're going to look at a web application built on top of this. And I'm going to just change my screen here. So this little demo application, it happens to be written in React and Redux. If you're not familiar with React or Redux, don't worry, it's not really part of this demo. It's an implementation detail. We're not going to, we'll try and avoid getting stuck into any of that stuff and focus on the logic of what Taquito can do for you. So this web application, the first thing it's going to do is we're going to give it a subject to vote on. I'm going to say, is blue a nice color? So this is our question that we're going to be voting on. Now the web application here is, the demo app is pre-configured with a secret key and the smart contracts that I mentioned earlier, that I showed earlier. So when I click originate here, underneath the covers, Taquito is creating a new operation to originate a contract. Originate is a term we use for essentially creating a new contract on the Tezos blockchain or deploying a new contract to the blockchain. It creates that operation. It'll do an estimation of gas, and then it'll sign it using our private key. And then it injects it into the blockchain and waits for it to be confirmed. And this demo is happening on the Carthage net, which is one of the Tezos test nets. So this one, this completed nice and quick. We now have the second page of our demo app here. And I'll go through this in detail. At the top here, we have an address that's KT1 address. So this is the new address of our smart contract that we've just originated. In Tezos, all smart contracts start with KT1, so you can always tell that it's a smart contract and not a regular address. I'm just going to copy this address and jump over to a indexer. I'm going to use TZ-stats right now. There's plenty of good indexers in the Tezos ecosystem. We can see that the smart contract was last active just a minute ago because we just created it. And if we click here on entry points, we can see the entry points that correspond to what I showed you earlier on. So we have vote, which takes a natural number, and the other administration methods. We can also click here on storage, and this will give us an idea of what's in here in the storage for the smart contract. TZ-stats does a good job of presenting storage in a friendly way that we see here. Okay, so I'm going to switch back to the demo app. Now, this smart contract, I mean, we have the name here of what we're voting on, and it has an end date. Then we have some sort of progress bars here, yay, nay, and pass. So no one has voted yet. Everything is showing 0. And below that, we have voters. This particular smart contract is implemented as a permissioned smart contract, meaning that only people, only addresses that are listed are allowed to vote. So this particular implementation isn't available. It's not possible for you to vote anonymously. Now you can easily change this logic should you wish to do so. And below this, we have a voter panel where we can vote yay, nay, or pass. here we have some radio buttons, and this is really specific to this demo to show you some technical aspects of Taquito, which we're going to get into. Taquito ships with several different implementations of signers. Now, a signer is what will create a signature for your operation. And if you want to make any change to the blockchain, you need to send an operation to it with a valid signature to affect any change. And we have an in-memory signer, which is really useful for development workflow. It allows you to basically do all your signing within your application. It's great for testing and demonstration purposes like this. It's easy to get started. It's not ideal if you're if you're making applications that deal with real tokens of value. Basically, don't use the in-memory signer in production. Use it for your development workflows. Now, we have also Testbridge, which is a popular developer web wallet, and I'll speak more about that in a moment. So the in-memory signer is selected at the moment, and it's the web app here is signaling to me that we have this address selected, and that shows up here as one of our voters. So I'm going to click Vote Yay on this. And Taquito is going to generate a new operation and estimate it and sign it, and then it's going to inject it or broadcast it to the blockchain. Now we get the status bar here going, and it completed very quickly. The block times on CarthageNet are 60 seconds. So if everything is running optimally, these operations can take anywhere between a couple of seconds and 60 seconds. It seems I'm lucking out today. And so now that this has completed, the web app, the demo app shows us some of the details of this operation, such as the hash of the operation, the gas it consumed, the fees consumed. And if we scroll up here now, we can see that Yay has 1/3 of the majority so far. We have 3 voters, so. Okay, before I jump into the code for this, I'm going to just use the Tezbridge signer. So Tezbridge is a popular developer-oriented web wallet for Tezos. And when I click on Testbridge, it's going to open up a new tab for me. And I have some wallets already pre-configured in here. So with Testbridge, I need to choose which wallet I want to use. I'm going to click Choose Signer, Local Managers. And I have one here called F1, which I have to unlock. And I'm going to click Use as Signer. So this is basically telling Testbridge that I want to use this address. Use this wallet. Now, if I switch back to the demo, down here under address, the address is updated to the one ending 5DC. So now I know that I'm using, or I have activated this address. I've selected this address for use with this this app, and I'm going to click Vote Yay because I just really like the color blue. And when I click Yay in that, it switches back to Tezbridge with a signing request. And in here, we can see that we have a signing request for a transaction. We can see the destination, which is the address, the KT1 address of our smart contract. And we can see the entry point, which is vote, and the value 1, which is corresponds to Yay. I'm going to click approve on this, and when I do, Tezbridge does its thing. It signs the operation, and it injects it directly into the Tezos testnet. I'll switch back to my demo, and we can see our progress bar has already started. We have new operation hash visible at the bottom here, and when this this operation gets included, we'll have it'll display us some more information at the bottom here, such as, again, the same as before, the gas that we used, and storage and so on. So while that's completing, I'm going to look over here at our code editor. We'll make this a little bit bigger. I hope you can all see okay. So in the code editor, we have again, I mentioned this is written in React Redux. That's an implementation detail. You know, don't get hung up if you're not familiar with any of those things. Our operation now for voting yes completed, and we can see the yes bar has gone up to 2/3 now. So I'm going to quickly go through the code. I won't go into too much detail. I have some slides that'll help us talk about some of these things in more depth. Here we have some components. At the top we have the contract panel, and below that we have the voter panel, which is the lower part of our demo app here. So we're gonna step into the voter panel. And in here we have a method called create Taquito. So this is what's going to give us a new instance of Taquito. For this demo, as you can see, it's using an in-memory signer with a hard-coded secret key. This is on testnet. This is a demo. You know, don't do this in production. We create a new instance of Taquito. There's conditional logic here to load the different signers, Testbridge signer and the in-memory signer. We also have a remote signer if you're using like kind of HSM based key storage. And you can also compose your own signer provided that it complies with our signing interface. So you can inject your own signer if you have some custom need or some other use case. This gives us an instance of Taquito. This is basically where all our APIs will be accessible. And as I scroll down the code here, I'm going to go to the voting form. We'll open this up here. And so in the voting form, down at the bottom here, we have our buttons, which is vote yay, vote nay, and pass. And these call the event handler vote. So let's look at the event handler vote. It takes a value of 1, 2, or 3. We're using TypeScript here. Taquito is written in TypeScript. But if you're building your web app, you can choose to use TypeScript. But I happen to recommend it. But you can just as well as easily use Taquito in a JavaScript application or anything that can make use of JavaScript. So in this method, we have a send voter operation, which contains our business logic for actually sending, casting a vote and sending it to the chain. So most of the magic happens in these 2 lines here, and in the slides I'll be getting into more detail about which each one does. The first line here, taquito.contracts.at. This takes a KT1 address as an argument, and underneath the covers here, it makes a request to a Tezos RPC node for this address. It downloads the Michelson script or the Michelson source code as well as the storage. Underneath the covers, it parses all of that Michelson and it creates a developer-friendly abstraction for this smart contract. On the second line here, we now have contract.method, methods.vote. Now this vote method is special. This isn't a method that's actually implemented somewhere in the Taquito codebase. This is a method that is actually defined in the smart contract on the chain. So when Taquito loads this Michelson, it parses the Michelson and it dynamically creates new methods based on the smart contract. And those methods take the appropriate arguments and values. So when we're dealing with a smart contract, we get these convenience, very familiar methods that are simply methods on a JavaScript object. The parameter here is vote, which is, again, a number 1, 2, or 3. And then we have the method send. Now, the send method does a lot of work. It composes our operation, generates the parameters to invoke the smart contract. It does some estimations, and then it forges a operation into the appropriate form for the RPC. And then it signs that operation. It produces a signature for that operation and puts those together and injects it into the blockchain. Now, the send method returns a returns a operation. So we have this op handle here, and the op handle has a method called confirmation, which returns a promise. That promise will resolve when the operation has been included into the blockchain. By default, it'll wait for 1 block. So as soon as it sees the operation on the blockchain, it actually monitors the head blocks in Tezos. As soon as it sees that operation, that promise will resolve. If you want to have more surety, so let's say you want to make sure your operation is for sure included, and it has plenty of validations, you can put a number in here such as 3 or 5, and then that promise will resolve after 5 blocks. So when that promise resolves, we then we call set receipt, which updates our user interface with the operation hash, our consumed gas, fee, and any storage that was dealt with. Below that, we have a catch. So you can see this is all wrapped up in a try catch. And I'll get into this in more detail in a moment, but I just want to show here that we can catch errors that are essentially thrown by the smart contract. So we do a type check on the error, and if it's a Tezos operation error, we know that it's something from the smart contract. From there, we can inspect the message, and we can handle the error appropriately. I'll show you how this is done in the context of the smart contract source code and Michelson in a moment. So that's the guts of the demo. I kind of wanted to contextualize this, you know, in a functional demo before we get into the details. So now I'm gonna switch back here to my slides. Okay. So we'll step through some of how to get started with Taquito, and with the demo kind of scene. We'll talk about some of what Taquito does in greater detail. So firstly, just a little bit about how Taquito is organized. The package structure is Taquito is organized as a monorepo. We have many different packages that get published to npm.js repository, as well as UMD deployments, so you can use them in script includes. At the top level of this mono repo, we have the package called Taquito, and this is where all the high-level abstractions for Taquito live. So if you're building an application, the majority of anything you would want to do should be possible using Taquito, the high-level API. But we have many more lower level packages, different packages for signing, for forging operations into bytes, for streaming, and so forth. And the high-level package Taquito is a composition of all the functionality in these lower levels. Now, in most cases, we define interfaces for these different functions with different implementations. So I mentioned before, we have an interface for signing, and we have implementations for in-memory, the Testbridge web wallet, and a remote signer. We also have an interface for forging. So you can use the Tezos RPC, send the Tezos RPC node a request to forge an operation, which is JSON, into bytes. We also implement local forging, so you can rely on Taquito to forge your operation into those bytes in memory in your own program. This is really useful if you're doing things like offline signing or air-gapped operations, and you want to have very tight control over this. So we see this in use in some institutions that want to have air-gapped offline cold storage keys. There's also a forger called Composite. This is useful in wallets. So Composite will forge your operation from JSON into the bytes using both methods. It'll use the Tezos RPC node, and it'll do it locally. And it'll compare the results from the two. And if it has a problem, if it sees a difference, it'll throw an error. So this gives you extra surety that the Tezos node you're using is doing its correct job, and your local code hasn't been compromised, or there's no bugs, for example. So it's basically doing and providing extra diligence with the composite implementation. Taquito being written in TypeScript, and the fact that we just really like type definitions. I mean, they make developers' lives a lot easier, we believe. We provide type coverage for all the different parts of Tezos. So on the left-hand side here, you can see a JSON object for a transaction. This is represented or defined as a type in Taquito on the right-hand side for the operation contents and the result transaction. To talk a little bit more about types, we're going to look at the Taquito RPC client. And again, the RPC client conforms to an interface, so you can actually inject your own RPC client should you wish, or override some of its default behavior. Now, our RPC client is essentially just a client for the Tezos RPC. All the methods in here map one-to-one with the Tezos RPC node. We don't provide any sort of composition or abstractions at this level. It's really one-to-one. What we do provide is type coverage for all the data coming from the Tezos RPC node. So when you work with the RPC node, you get nice types. This is really like, it gives you good developer user experience for things like, code completion, refactoring, and so forth. What we do additionally is that we provide type coverage across protocol versions. So at the very bottom of the slide here, we have a type called contract response, which is a union type of contract response 004 and 005. So 004 refers to the Athens protocol, and 005 refers to the Babylon protocol. So when Tezos upgraded, it went from Athens to Babylon, and now we're currently on Carthage. The next protocol will be some city beginning with D, maybe Damascus or Dublin, I don't know. If you look at the definition for contract response 004, you can see it has these properties: manager and spendable. Now, when the blockchain upgraded to Babylon, that protocol upgrade refactored how some things worked, and it removed those two properties, manager and spendable. So if you had written an application during the times of Athens, the Tezos Athens protocol, and you were relying on the manager expendable property, and you upgraded your version of Taquito to the next version that supports Babylon, your code will break. So you'll get a compile time error, which is, it's like, oh great, Taquito, you broke my code. That's actually a really strong value proposition, because breaking your code early on in your development environment is much nicer than getting a call after a protocol transition and your application isn't working. So we do a lot of legwork on understanding these new changes in future versions before they actually roll in. And we release support for future versions before they actually become active on the blockchain. This means that it reduces a lot of work you guys need to do in terms of maintenance and staying up to date so that your applications work with the next version. It doesn't mean you get to do nothing. You still need to test and figure that out. But our goal and our hope is that we'll significantly reduce that maintenance burden for you. A quick note on installing Taquito. As I said, it's published to npm.js, so you can do npm install or yarn install. All our npm packages are signed with our GPG keys, so you can verify the signatures for these to tell that they're authentic. Hopefully mitigating risks in software supply chain attacks. We also publish minified versions of Taquito to content CDN, so you can include them in your HTML pages if you want to. And for those, we also publish integrity hashes as well with each release, and those integrity hashes are published in our release notes. Okay, So getting to use Tezos, you can either import the singleton Tezos from the package Taquito, and this will give you, all your methods and so on. You can also new up a new instance of Tezos using the Tezos toolkit method, and this gives you a independent instance. This is useful if you're dealing with multiple keys, or maybe you want to have an application that's dealing with different RPC nodes. You can configure these instances independently and differently. A little bit about injecting providers, because that's kind of an important thing. The defaults when you get a new instance of Taquito, there's no signer configured by default. We want you guys to make a conscious choice on what you're using as a signer. And you can use like a wallet signer such as Testbridge in memory. The RPC node, forger, and the streamer, these are all configured by default, but you can easily override them. You can also provide override configuration here. So you can adjust the polling intervals for waiting for new operations. So we give you a promise that resolves for when you inject an operation. And underneath the covers, Taquito actually pulls the Tezos RPC node. And you can control how aggressively or passively it will pull the node for you. You can set things like timeouts and such here as well. At some point, we'll change the implementation for polling to also allow some form of streaming implementation as well. That's more optimal. And then you can also specify the protocol to use when interacting with the RPC node. This is a little bit lower level, but you don't need to specify this by usually. Tezos Taquito will actually introspect from the Tezos node to see which is the active protocol. So if your application is running during a protocol upgrade, Taquito automatically detects which protocol is in use, and it automatically selects the correct one. This means that you don't have to do any sort of upgrades, at 11 p.m. at night when the blockchain is upgrading. You can deploy your application using the latest version of Taquito, and it should transition and continue working before and after. Okay, so to inject a provider, we look at in-memory signer here. The first two lines here basically provide the in-memory signer with a private key. And the second example is configuring it with the Testbridge web wallet signer. So it's as easy as that. You simply create a new instance and you set it with the set provider method. You can also import encrypted private keys, plain text private keys. You can import faucet keys from the testnet faucet website, or your fundraiser keys if you're doing this with fundraiser keys on mainnet, for example. Okay, so we'll talk a little bit more about contracts. We have some snippets of demo code here that kind of correspond to the demo I showed you already. We'll talk a bit more about the transaction operation and generally about our Taquito smart contract abstraction and storage abstractions. So we'll start with the storage, the smart contract abstraction. And what this provides you is it gives you a friendly representation of your smart contract storage. So instead of dealing with a lot of JSONified Michelson and interpreting all of that data, you get a JSON object with properties that should feel very familiar to any developer. We also provide friendly ways of accessing and setting big elements in big maps. So big maps in Tezos are lazy loaded maps. They're useful for keeping storage costs down on smart contracts. And then we also expose the entry points for the smart contract with methods and smart contract errors. So here's this line again. So we call this this at method on our smart contract, and Taquito fetches that Michelson code from the chain. we parse it, and then we generate a friendly abstraction for that contract. So just to give a little bit of context here of what's happening. So when Taquito fetches the Michelson code for the storage and the Michelson script for the contract, it's getting back a large JSON representation of Michelson. And you can see on the right-hand side here, we have this JSON sort of tree structure that has like a prim and a pair that has a child of another prim and pair, and there's another prim and pair, and that has some more values. And then we're kind of going back up again, and there's another sort of branch of this. And this is pretty tedious to traverse as a developer to kind of figure out what's going on here. So Taquito aims to make this easier to deal with. So when we load that data into Taquito, we produce a JSON object. So on the left, the two top lines here are showing us fetching the storage for this particular contract. And in that storage object, we have it's a standard object with properties such as admins, end date, proposal, the name of the proposal, and the voters and the cast votes. On the right-hand side of this, we have a LEGO type definition for the storage of this particular contract. And so, LEGO does a lot to make working with Michelson friendlier. It's a high-level language, and it allows you to define these types, like you see on the right-hand side. We love LEGO. But it's worth just mentioning again is that Taquito works from bottom up. We're not tied to LEGO. To use Taquito, you really are using Tezos. You can choose to use whatever high-level language you wish. It could be LEGO, it could be SmartPy or Juvix or any of these other languages, or you can write your contracts directly in Michelson if you want to do that. Then, so here's a quick example of what we see with a big map. So in on the as I mentioned before, a big map is a lazy loaded map. And in order to fetch values from a big map, you have to do a lot of kind of, I dare say, obscure kind of, tedious encoding of keys and so on to get data out of the RPCs. We make that a bit easier. So on this particular contract example, and this isn't the voting contract. The voting contract actually doesn't implement a big map, but this type def does. So we have a big map here. The name of it is ledger. And in order to get data from that ledger property, we simply call .get. And equally, you can call .set on that as well. And that allows you to interact with these big maps. Michelson supports using pairs or tuples as keys for big maps as well, and Taquito also supports this as well. Okay, so then we'll go over interacting with the smart contract here again. I showed you the vote method earlier on in the VS Code editor, but I just want to show you all of them here. So on the right-hand side, we have a type definition for the entry points from, again, written in LEGO. And we have vote, start vote, remove admin, and add voters. Each of these get compiled by LEGO into Michelson, sent to the chain. And then later on, Taquito will come along and read that Michelson. From the Michelson that it gets on the chain, it basically parses that and it figures out what methods it's going to create. So it dynamically generates at runtime these methods vote, start vote, and so forth. And it also figures out the types for the params. So at the bottom here, most of these are quite simple. They're single values that they take. Add voters takes a map, and we're using a computed key there at the bottom for address, and with the value of 1. So we'll look a little bit more about the transaction operation. This particular method we're calling here is add voters, and it's taking a computed key for address with a value of 1. And this is adding a voter to the approved voters list of our smart contract. And you can see there it's calling .send, which does all our business logic. From that, we get the operation handle, which we can wait on. We call confirmation to wait on the promise, and then we can log out the results. The .send method does a lot of work for you. It's a pretty large abstraction. Now, all of the work that .sends does, it's all compositions of lower level packages. So if you want to estimate or sign or forge, or you want some of the data from this process, and you want lower level control, that's completely open. They're all public methods in the Taquito toolkit. So we give you these high level abstractions to get going quickly, but the sort of trade off with higher level abstractions is that you sometimes lose control. And you know, it's our goal. We want to do our best to keep you in control, keep you and allow you to get down into the lower level detail if you need it. And then we'll look a little bit about at error handling in a smart contract. So in Michelson, we have a fail with instruction, and this basically allows Michelson to signal to the caller that there's been an error with the operation. And when fail with is called, the whole operation is unwinds, and no change is affected to the blockchain. Lego, being a higher level language, has a method that corresponds to this called fail with. So you can kind of consider this to be nearly similar to throwing in an exception. And this method here that we're looking at, this function definition, it's checking if the sender of the operation is listed in a list of admin addresses. So it checks with an if statement whether it's there or not, and if it's not there, it throws an error. It fails with the error e_no_priv. Now this is a string here. You can write, you know, the natural language saying like the sender does not have enough privilege. We tend to prefer using error style codes as opposed to natural language, but that's up to you. How this corresponds in Taquito is that you basically use a try-catch, and if Taquito detects an error thrown by the chain, thrown by the operation, it'll catch that error, and you can do a type check on the exception. And if it's an instance of Tezos operation error, then you know that it's something coming from the chain. And you can inspect the message for the corresponding error message from your smart contract. You know, we're probably seeing more contract interface specifications using standardized error messages. You know, if you're dealing with an asset contract, for example, you can, if the errors are defined in the specification, then you have, you know what to expect, and you can handle those error conditions gracefully and in a way that makes sense to your users. So I think we're running a little bit ahead of time, but that's the presentation, the material that I have to run through today. Really, I was really happy to do this webinar, and I'm excited to see what you guys all build in this CoinList hackathon. You can follow me on Twitter or reach out to me via DM. My DMs are open. We are occasionally hiring for people who are super interested in Tezos and are really interested in TypeScript and library development. So if that's something that you're curious about, you can also consider reaching out to me. Yeah, hopefully we, Spencer, do we have any questions?
Yeah, there is actually one question. So the question is, how does Taquito work with Tezos protocol upgrades? Do you need to upgrade Taquito before or after the upgrade?
Oh, okay, yeah. Yeah, so we, We have a versioning scheme. So currently we're on version 6 of Taquito. And we sort of follow the Semver versioning pattern, but we abuse it a little bit. So the major number is version 6 at the moment, and that corresponds to protocol 6, which is Carthage.net. When we add support for the next protocol, which we will do speculatively because we don't know for sure if it's going to become the next protocol until later on in the process, but we will add and develop support for that early on. Before the protocol transition happens, we'll publish new versions of Taquito, which would be version 7. When you're on version 7, it's still compatible with version 6. So everything will work on version 6, even though you're on version 7 for forging, injecting operations, reading old data. That all continues to work. When the chain transitions to version 7, Taquito will queries the chain every time to make sure to check what's the current version. And then it loads the correct implementation internally for that protocol. So the short question is, Taquito will work with the current and the next protocol even during transition. So you don't have to upgrade your application at a specific time during the protocol. You can upgrade it a few weeks before the transition happens to the new version of Tezos.
Cool. Does anyone else have any other questions? So it looks like no other questions so far. But yeah, thanks again for your time, Jeff. I will upload this to YouTube as soon as I can. And yeah, I'm looking forward to the hackathon itself. For those of you who are here today, if you are looking for teammates, there is going to be a team building session tomorrow at the same time. You probably have received an email from me. If you would like to attend the session, please fill out the Google form for it. But otherwise, yeah, thank you guys for your time, and especially thanks, Jeb, for your time.
My pleasure. And if anybody does have questions after this, feel free to reach out to me. Also, just want to emphasize again, Taquito is open source. We're contributor friendly. So if it's anything as simple as finding a typo in our documentation or wanting to implement some cool feature, open an issue on GitHub, and yeah, we'd love to hear from you. Thank you all.
Yep, awesome. Have a good one, everyone.